8.1, solving systems of equations by graphing. So our second objective here is to find the solution of a system of equations by graphing it. So first we were just finding out what is a solution. Now we're going to graph our solutions. So does a system of equation have to have only one solution? And this is a question that we're going to keep coming back to. So by the end of this lecture, you should be able to answer this question. So at the end of the lecture, I want you to answer or be able to come to class and tell me the answer to this question. Does a system of equations have only one solution? Well, our first example of solving by graphing, we have x plus y equals 3 and x minus 2y is equal to 0. So we're going to graph both of these equations on the same graph. So your first part is to graph on the same graph. So that being said, to be able to graph them, to graph this equation, I found my x and y intercepts. So x plus y is equal to 0. To find my x and y intercepts, I do x plus 0 is equal to 3. So my x-intercept is at 3, 0. And then I do 0 plus y is equal to 3. So my y-intercept is at 0, 3. For this one, to graph that, I could do my x and y intercepts, but they're going to be the same. They're both going to be at 0, 0. So the other way to graph that is I can plug it into y equals mx plus b. So I would do x minus 2y is equal to 0. Subtract x from both sides, negative 2y is equal to negative x. Divide by negative 2, and y is equal to 1/2 x. So I put a point at 0, 0, up 1, over 2, and gives me my next point. So that is equivalent to that equation. So now I graph them, and I see that they both meet at this point right here. So the solution to my set of equations is at 1, 2, so 2, comma, and I go up 1. So 2, 1 is the solution to my set of equations. Alright, let's try again. So solve by graphing. We have two different equations here. I'm going to set them both equal to y to make it a little bit easier for me to solve. These ones aren't as easy to find the y-intercepts. So I'm going to subtract x from both sides. I get 2y is equal to negative x plus 7. Divide by 2, and I end up with y is equal to negative 1/2 x plus 7/2. And here I'm going to subtract 4 minus 4. I'm going to rewrite as y equals x minus 4. So now I have my two equations that I'm going to graph, which is this one right here and this one right here. So I'm going to go up to 7/2, which is 4.5, or 3.5. 1, 2, 3, and a little bit. So right about there. And my slope is down 1 over 1, 2. Down 1, 1, 2. And I'll create my line. And that's a pretty good estimate. So now I'll do my next line. I'm going to cut through -4, so 1, 2, 3, 4. And my slope is up 1 over 1. So now that I can see, this is the point of intersection. So my solution is 1, 2, 3, 4, 5, comma 1 is my solution. And I can always check that by plugging it into both equations, and if you plug it into both equations, it should work. So in this case, it would, in the first one, 5 plus 2 is equal to 7, yes, and 1 plus 4 is equal to 5. Alright, so another piece of information that you're going to need to know is consistent systems. Consistent systems have different slopes, so they have one solution. They could have the same y-intercepts, but they have different slopes, and they consist of just one solution. They meet at one point. Dependent systems have the same line. They are the same line. So, dependent systems have the same slope, the same y-intercept, and they have an infinite amount of solutions. That is that all their values are solutions. Inconsistent systems have no solutions. Inconsistent systems have no solutions, and that's because they're parallel lines. They have different y-intercepts, but they have the same slope. So you're going to copy this down and graph each one of these, solve by graphing, and come up with whether on the bottom of each one, tell me which one is consistent, which one is inconsistent, and which one is dependent. So consistent, inconsistent, and dependent. As you graph them, you'll determine which ones are the same lines. I want this in your notes. And then here's another one for you to solve by graphing. Find the point of intersection.